Continuing with question number 7. The diameter of the moon is approximately 1/4 the diameter of the earth. Find the ratio of the surface area. That means I have to divide both the surface area, right, of the moon and the earth. So this is for the earth and this is the moon. I've taken the radius to be R1 and R2. Now let's go back to the question, solution. I'm taking the diameter of the earth to be D1. Clear? Now let's find the diameter of the moon. I'm taking it to be D2. If you look at the question, it says the diameter of the moon is approximately 1/4. As you can see, 1/4 came here, right? 1/4 the diameter of the earth. What is the diameter of the earth? D1. Clear? So 1/4 into D1. And if I multiply, I'll get D1 by 4. So the diameter is down. Now let's find the radius. Pretty simple. Radius of the earth, I'm taking it to be R1. I just have to divide by 2, right? So D1 by 2. Now radius of the moon, you will see same thing, right? It will be divided by 2. But if you look at the diameter, it is D1 by 4. So you can see here D1 by 4 is here, and this 2 is there because I have to divide by 2. And then if I multiply now, I'll get D1 by 4 to the 8. Now like I said, we just have to divide their surface area, right? And we know that the earth and the moon, the shape is a sphere, right? So 4 pi r square 1 divided by 4 pi r square 2. Then you can divide 4 pi from here. And if you look at R1 is D1 by 2, right? So it is here. And then R2 is D1 by 8. So remember the whole square. All right. Now what I'm going to do, I'll try to change this division here into multiplication. That means how will I get? Remember, nothing happens to the first, whatever is up there, right? So D1 by 2 the whole square. Now this division, I'll change it into the multiplication. That means the lower portion, they will change their position. So 8 divided by D1 the whole square, right? Then D1 into D1, I'll get D1 squared, and 2 2s I'll get 4. 8 8 is 64, again D1 square, right? Once I'm done with that, 4 1s are 4, 4 1s are 4, 4 6 are 24, and this D1 square and D1 square can be cancelled. So I'll just have 16 by 1, or I'll get the ratio to be, the ratio of the surface area to be 1:16. Alright, question number 8. A hemispherical bowl is made out of brass 0.25 in thickness. So this is the thickness, alright? How much? 0.25, the thickness of the bowl. Clear? The inner radius of the ball is 5 centimeter. Inner means from here till here is 5. Find the outer curved surface area. Outer, right? So I have to only find this outer curved surface area, which means I still need to know the outer radius, right? Outer radius means it will be from here till here, which will be the addition of 5, right? Plus the thickness 0.25, and I'm going to get the outer radius to be 5.25 centimeter. And like they said, I have to find the outer curved surface area of the hemisphere, right, which is this region. Of course, backside also, right? So the formula is already what? Twice pi r square. So remember, inner I took small, and then outer I took capital R. So once we put the value, pi is 20 by 7, and then the outer radius is how much? 5.25, right? Radius square, so 2 times, then 7 to 7, 7 7s are 49, 7 5s are 35, right? So we can't go much further than this. You just have to multiply everything. 2 into 22 is 0.75 into 5.25. Once you multiply, we'll get the outer curved surface area to be 173.25 centimeter square. All right, let's do one more. Question number 9, the last one. A right circular cylinder, right? You can see the cylinder here, just encloses a sphere of radius r. Alright, what are asking us to find? The surface area of the sphere, the curved surface area of the cylinder, ratio of the area obtained in 1 and 2. Alright, so I'm taking the radius of the sphere to be r. That means from here till here, right? And then of course you will notice that even the radius of the cylinder is equal to radius of the sphere, because remember, cylinder, the radius will be from here till here, which will be the same with the radius of the sphere. Clear? So they are both same, r and r. Now height of the cylinder, if you look, see, if I take the sphere, because remember this is just touching the top, okay? So touching the top and also the bottom, just encloses, right? That means it is the sphere is touching the top of the cylinder, in simple words. All right. So if you look here, this gives us the diameter of the sphere, right? And we know that from here till the top is r, and then from here till the bottom is also r. But if you look properly, it will give us the height of the cylinder. Alright, so height of the cylinder is what? R plus R. I'm going to get 2 times R. Now let us try to find the surface area of the sphere. Surface area of the sphere, what is the formula? 4 pi r square, right? Also, the second part, they told us to find a curved surface area of the cylinder again, this region again, right? So twice pi r h. But like you will notice, what is the height of the cylinder? In place of the curved surface area, the formula is what? 2 times pi r h, right? Now if you look at the height of the cylinder is what? H is 2 times r, right? So in place of h, I'm simply writing down 2 times r. Clear? Now you can see that I can multiply 2 to the 4, right? And then r into r will give me r square. Clear? So there is a curved surface area of the cylinder. Let's find the last ratio of the areas obtained in 1 and 2. Ratio means I have to divide, right? So surface area of the sphere divided by curved surface area of the cylinder. Now if you look at the surface area of the sphere, 4 pi r square. Also if you look at the curved surface area of the cylinder, it is 4 pi r square. So you can see here 4 pi r square, which I can divide. I'm going to get 1 by 1, or the ratio is 1:1.